Namaste everyone. Today we are solving questions related to GATE and CSIRnet. One question is there: L equal to limit n tends to infinity 1 by n root under n factorial, then L बराबर 0, L equal to 0, L equal to 1, L is between 0 to infinity, L is equal to infinity. Result. One result we know that if an is greater than 0, means this term as an we take. If an is greater than 0 and an is divergent, if it is positive and divergent, then limit this term is an, this downside term it is an. Or they're saying if an is greater than 0 and an is divergent, then limit a1 by an is equal to 0. So limit n tends to infinity n factorial to the power 1 by n. We can write this in this form, and n tends to infinity, at n tends to infinity. If we are not writing anything here, like n tends to 1, infinity, whatever, then you have to understand it is n tends to infinity. Otherwise we will mention here limit n tends to infinity, limit n factorial to the power 1 by n is equal to infinity. Limit 1 by n factorial to the power 1 by n is equal to 0. Limit n factorial to the power 1 by n is equal to infinity. Limit 1 by n factorial to the power 1 by n equal to 0. 1 by infinity is 0. So since it is infinity, so it is 0 by this, means it is divergent. Infinity means divergent, so it is 0. So option, which one is correct? The L is 0. L is 0 means option A is correct. Now another question is there. Consider the sequence an equal to 1 plus minus 1 to the power n 1 by n whole to the power n. Then limit supremum of an n tends to infinity is equal to limit infimum of an n tends to infinity is equal to 1. Limit supremum an n tends to infinity is equal to limit infimum an n tends to infinity equal to e. Limit supremum of an and limit infimum of an is equal to 1 by. Limit supremum of an is e and limit infimum of an is e. So we will take this an and we will try to know what is the supremum, what is the infimum of an. So this is the an. So as we know, in complementary subsequences, through complementary subsequences, what we are doing, we are to try to find the even term, a to n. So in place of n, you can write 2n, so 1 plus minus 1 to the power here 2n, so n minus 1 to the power even, so it is plus 1, so no need to write here 1 by 2n all to the power 2n. Here 2n plus 1 minus 1 minus 1 by 2n plus 1. In place of 2n, it is 2n plus 1. Okay, what they are doing here a to n, this one, and a to n plus 1, this one, form complementary subsequence of an. We have created complementary subsequence. Okay, so now here as you see here how it is minus 1, because minus 1 to the power odd, 2n plus 1 is odd, so odd, so it will come minus. So a to n will go to e. How it will go to e? This one limit we know that e to the power this 1 by 2n into 2n. So 2n to n cancel, so e to the power 1 means e. Here also limit of this is equal to e to the power this with minus 1 by 2 plus 2n plus 1 into 2n plus 1. 2n plus 1, 2n plus 1 cancel, so e to the power minus 1. E to the power minus 1 is equal to 1 by e. Okay, so as we able to know that even term is going to e and odd term is going to 1 by e. Hence an has only 2 limit points. How many limit points it has? It has 2 limit points, e and 1 by 2. And which one is supremum and infimum? We know that e is supremum, so limit superior of an is e and limit inferior of an is 1 by e. So option D is correct. What is option D? Limit supremum of an is e, limit inferior of an is 1 by e. Okay, this is the question 5. Question 6 is next question. Limit n tends to infinity 1 by n factorial 1 by 1 under root 1 plus under root 3 plus 1 by under root 3 plus 1 under root 5 plus dot 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 1 by under root 2n plus minus 1 plus dot under root 2n plus 1 equals this one is equal to which? Root 2, 1 by root 2, root 2 plus 1, 1 by root 2 plus. To find we will able to know that equation option B is correct, 1 by root 2 is correct. To find limit and between 1 by 2, we will write these all term here. Okay, now what we will do, we will write this, like we will solve this one. How we will solve this one? We will multiply its like under root 1 minus under root 3 upside and downside also. So it will come this way, and downside a plus b into a minus b barabar a square minus b square means it will come minus 2 here minus 2, here also minus 2 it will come. In each term it will come minus 2, so minus 2 is common, and here upside it will come this one just negative, this one in negative, and this one in negative. It will come like that. So minus 1 by 2 is there downside. So what we are doing, minus 2 outside we are taking. So 1 by root n is already there, 1 by 2 is there, minus 1 is we are taking. Here what we will do, this will cancel, this cancel. Only first term, this one, and last term will be there. So under root 1 minus under root 2n plus 1, this will be there. After that what we will do, minus 1 by 2, limit n tends to infinity to 1 by 10 under root n we will take common. So 1 under root 1 by n minus under root 2n plus 1 by n. Okay, now n cancel. So what, minus 1 by 2, limit n tends to infinity, this and this, and n can taken common, cancel. So here it will come like that. Okay, now 1 by 2 is there, limit n tends to infinity, it will change. If you multiply this minus, so this come, and now as n tends to infinity, 1 by 2 is 0, root 2 minus 1 by infinity 0. So root 2 it will come. So it will come root 2 by 2, it will come 1 by root 2. So option B is correct, 1 by root 2. Now another question. Only 2 questions is there. Let px be a polynomial in real value x of degree 5. Px, what is px? Px is the polynomial in real value x of degree 5. How many degrees is there? 5. Then n tends to infinity, pn by 2 power n is 5, 1, 0, infinity, which one? So let px equal to ak x to the power k plus ak minus 1 x to the power k minus 1 plus dot 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 an. Limit x tends to infinity, ak x to the power k plus ak minus 1 x to the power k minus 1 plus dot 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 a naught by 2 power x. Now we will separate this like we will put 2 power x, we will give every term. So what will come, ak x to the power k by 2 power x, like that it will come. As for large x, s power k less than 2 power x, if you take large x, if you take 5, let's say 5, 2 power 5 is more than 5 to the power k. Okay, thus limit n tends to infinity, pn by 2 power n is equal to 0. This one will come 0. Here as you can see, x tends to infinity is there, and this one is larger than this one. So this one is larger than the one, so this one will tends to infinity faster than this one. So it will it is constant by something, infinity, towards infinity. So 1 by infinity 0. So in this way it all will become 0. So 1 by all, sum of all is 0. Or take x power, or take x per px equal to x power 5. If you take x per power 5, here you fix in place of k, it is 5, 4, 3, 2, 1, like that. 1, 0. 2 power x, 2 power x, 2 power x. Then what will happen? Px equal to x. In this way it will also come 0, and use L'Hopital rule.
you can use L'Hopital rule to solve this. You can use
this way also. Another question is there. Limit n tends to infinity 1 minus 1 by n square whole to the power n equals 1 e to the power minus 1 by 2, e to the power minus 2, e to the power minus 1. What is the solution? So we will know, we will solve this one. Limit n tends to infinity, we will write this one. It is of the form 1 to the power infinity. If you put all infinity 1 by infinity 0, it is infinity. So it is of the form 1 by infinity, this form. So we will write it this form. So we know that if it is 1 by power infinity form, then we can write this j e to the power limit n tends to infinity, this into this one, minus 1 into this, minus cancel this n will get cancelled, so minus 1 by n tends to infinity, 1 by infinity 0, e to the power 0, or we can write it this way here, n tends to infinity 0 is to the 0 question 0, e to the power 0, it is 1, so 1 by 1 is 1, so its answer is 1a. So in this way, this is the completion of these questions. So if you have any query, then you can ask in comment. Thank you.